welcome. Thank you for joining us this morning, or afternoon or evening, depending on where you're located. My name is Michael Kelly. I'm a senior research analyst with Guidehouse Insights. And I'd like to welcome everyone today to our discussion on the future of DERMS for grid optimization. We're lucky enough to have with us today an esteemed panel of experts from both Schneider Electric as well as AutoGrid. Now, prior to jumping into our discussion, I'd like to briefly introduce each of these panelists. Beginning with Schneider Electric, we have the Senior Vice President of the Digital Grid Business Line, Alexei Greno.
Hello everybody.
It's Alexei. I'd also like to welcome from the Schneider Electric team, Vice President of Global Strategy, Innovation, and Marketing, Scott Kohler.
Hello. Hey, thanks, Michael.
Thanks, Scott. And lastly, from AutoGrid, we have the Senior Director of Industry Solutions, Sadia Ravindran.
Hi, Mike. Thank you for having us.
Great, thanks. So thank you all for participating today. This is certainly an important and timely discussion as it pertains to electric utilities, the energy industry as a whole. To help set the stage a bit, I was hoping that each of you could help speak to some of the emerging macro trends that you're seeing that are helping to drive the need for some of these more holistic DERMS solutions.
Well, thanks, Mike, and hello, everybody. So as Mike is saying, I'm Alexis Greno. I'm Senior VP leading the digital grid business. I'm really happy to be here with you all to talk about this tremendous evolution of the utility landscape. But it's not only utilities, it goes all the way down to prosumers. So to talk about mega trends, let's start by business and regulatory trends. DER are distributed energy resources deployments, and their connection to the grid are rapidly increasing, which is pushing our electric infrastructures beyond their historical purposes. The International Energy Agency estimates that from 2017 to 2020, there was 179 gigawatts of distributed solar added, which represents roughly 15% of US generation capacity in 2021. While the stock of electric vehicles also tripled to over 11 million. This is only expected to increase with more car manufacturers announcing plans to transition to full EV fleet by 2030 or 2035. Furthermore, the boom in renewable energy looks set to continue due to falling prices from economies of scale and advancement of science and technology. So utilities face enormous challenges for more decarbonization and deployment of DER on the one hand, and extreme weather events causing issues to forecast and issues of reliability of the supply on the other hand. So there is a commonality of many drivers coming together from more decarbonization, decentralization, digitization, and electrification. But the way that regulations are adapting and business models are changing varies from region to region. So there is no one deployment approach right for all. Utilities need a technology partner who can meet their requirement today and provide a future-proof solution as their needs evolve. So with a continued widespread adoption of digitization, traditional energy sector business models have been completely revamped. Utilities are seeking new business models and technology solutions to manage this growth in DER in a way that benefits the end consumer and the grid alike. So you see the tremendous trend that we're seeing in businesses and regulatory. But now I hand over to my colleague and partner, Scott, to talk about more technology trends.
Yeah, thanks, Alexei. Yeah, and this is a brief introduction for myself. I run strategy, innovation, and marketing for our digital grid business. And really, we think of this as a comprehensive portfolio of solutions around asset management, operations, and edge management, and how all these things work together, and how we innovate the partnerships we have, acquisitions we're making, innovation investments, all of these things that strategically help move our industry, our company, and our customers forward. Alexi, you're talking about electrical systems being demanded in many new ways. They got to be more flexible to support all this increased complexity, especially with more distributed energy resources connecting. And another way I think of this is we're all trying to evolve the greatest engineering achievement of the 20th century to adapt to these very complex needs of the 21st century. So you have a legacy infrastructure that is now being asked to perform that it wasn't originally designed. And obviously that brings up a lot of potential challenges and issues. We're certainly not going to just completely replace our electric infrastructure. And so when we look at this, what are the opportunities that come out of this? More smart inverters are connecting, and we have various grid constraints. So we have reverse power flow situations, spiking voltage, overload events. But if we have more awareness of where these resources are and the ones that we can actually monitor and even better dispatch in a coordinated fashion, then we can help mitigate these. And so to take advantage of this, we need to model and forecast current and future state of distributed resources. Then we can start optimizing management and control and really help drive and support all the main critical priorities in our industry, which encapsulate reliability and resilience, operational efficiency, grid flexibility, and sustainability. And all of this, we're talking a lot about technology. Technology is really an enabler. There's a lot of business processes, regulations, other things that are adapting as well. But to help best address issues we have in the near term, while more and more things are being advanced, technology really has a great role to help. And the best way is to take a holistic view of short and long-term factors. So it's not going to be solved by just specific point solutions running in isolation, but really grid operations and planning and all functions, customer service, must be coordinated with flexibility services, prosumer engagement that really optimizes energy across energy markets, prosumer priorities, and the grid needs. So I guess with that, I'd like to hand it over to Sadia to talk a little bit about some other aspects of technology.
Thank you, Scott. Yeah, so I think as Alexi talked about, DRs are being deployed at this accelerated and astronomical pace. And along with that deployment comes high volumes of data. Mm-hmm. The International Data Corporation predicts the data volumes will grow from 33 zettabytes in 2018 to 5 times that by 2025. And this trend also obviously applies in the context of energy sector, with millions of these DERs being deployed on the electric power grid. So grid operators must embrace data-powered insights, as these can create new business value through better infrastructure management, more efficient operations, and as Scott alluded to earlier, improved services being delivered to end customers. But delivering such insights will require platforms that utilize the latest technologies to ingest, process, and action insights derived from this data in real time and at scale. And a data-driven approach combined with artificial intelligence and machine learning techniques can be used to optimize the capital costs, reduce the operational costs, and ultimately drive the transition from consumer to prosumer. So it is a technology solution that's combined with business models and workflow and process innovation that can be used to deliver a more comprehensive approach to DERMS.
So building off of some of these trends that you had all mentioned that we're seeing in the market, one concept that I see that's brought up over and over again by DERMS vendors, utilities alike, is this idea of the DER lifecycle. So I was hoping you can speak to that concept just a little bit for our audience.
Yeah, thanks, Mike. So I'll start on this DER lifecycle. Actually, when we talk about DER lifecycle, we talk really about, it's about from engaging to planning to designing, monitoring, operating, optimizing, and maintaining. So that's really the full life cycle. Utilities end users and industry at large need a stepwise approach to digital transformation and grid data management. So this will enable a greater adoption of distributed energy resources, better matching also with the legacy of past investment, with existing infrastructure, with the regulatory environment, and the specific challenges of grid operators and end consumers alike.
Yeah. And just to build off of that, the comprehensive or full DER lifecycle management is more than just about addressing one or two business functions. It's about how all of the various functions within a utility and an energy company work together, how data is shared, what user interfaces are made available to specific types of business users, and so on. Having solutions that are designed and developed to coordinate across business functions is the key to simplifying implementation and maintenance. Very often we have conversations with utility executives who talk about how they have point solutions that are deployed all across their IT and OT infrastructure, and there is no way or no system of systems orchestration approach that's being deployed to coordinate across these solutions. And that's something that utilities can really benefit from, even if they start with the most important and near-term needs first, and then expand the complexity and the use cases that they're delivering through this coordinated approach over time as their needs evolve.
Yeah, this concept of a coordinated end-to-end approach, it's really interesting because it's everything about optimizing supply and demand across all locations on the grid. So not just more traditionally thinking about transmission, but everything at the distribution level. So throughout commercial industrial districts, residential neighborhoods, this idea of optimizing supply and demand is more and more important as more and more energy is being generated at all different types of locations. And Sadia, I like what you said too about this idea of technology helping coordinate and automate business processes. And really the best way to get maximum value, how to share information, how to share it more simply, have it pre-integrated approaches, out of the box needs that understands that a certain technology solution or application may need certain data and also could share information with other systems, and how automating that process reduces data errors. It basically makes things more efficient and fast, and you have less needs of users that have to completely guide the system. They have access to information, can make decisions, but the more we can automate, the more we can build a scalable solution. So this holistic approach really is about being scalable and sustainable. And the other aspect too is managing DER is not just about a massive platform that is now touching everything within a service territory and all systems. It's an evolutionary approach. So you generally start with small number of resources. That's another aspect of scaling up over time. But if you think about this ahead and organize it appropriately, you can avoid some of what you said, Sadia, about these various different point solutions that either have to be replaced or changed or customized to work within a better enterprise environment.
Interesting. So prior to jumping into the next question, I would like to invite any and all audience members to ask any questions in the chat. Following our discussion, we can turn to some of those audience Q&A. Now, guys, in relation to this more comprehensive end-to-end approach to DERMS, I'm curious, what are some of the key functionalities you see in use by utilities today versus what might be required tomorrow?
So Mike, on this one, I mean, Scott talked about, sharing information across systems. And I think first it's about visibility. When we talk about distributed energy resources, utilities usually lack the situational awareness of connected DER. So the foundation of building up the system and DERMS capabilities is to start with modeling the location, the type, the size, and the status of DER that is presented in various views, including geospatial. Right? So from here, the impact of DER can be analyzed and forecasted, including such insight as estimating hidden load and constraint issues such as reversed power flow, overload, overvoltage, etc. So this information will serve as the basis for all other capabilities and benefits, and can be shared across stakeholders, internal and actually external to the enterprise. So Scott, maybe you want to expand on also some other features like planning.
Yeah, sure. You're absolutely right. I mean, I get asked a lot from different utility executives that, what's the appropriate place to start? So you can look at a challenge. So set a high target, a major goal, and maybe this can be, when you're a business entity is going to become carbon neutral, and you start working backward, and you start working to what are the steps I need to take now. And what you said lays the foundation for everything else. And most utilities really don't have much visibility into distributed energy resources today. And once you have that, now we start thinking of, and I'll kind of expand a little bit on planning aspects. So hosting capacity is a quite a popular need to understand where network capacity is struggling and causing good constraints. So, there's a lot of different industry stakeholders that need this information. Making this more transparent and available is quite important. This can be all the way from visualizing it in many different ways, from a geospatial view and traffic light, where you have sort of a red zone, yellow and green. You can have this be tabular. You can have this enabled on the web for different folks. And really get a sense of, okay, I already know that if I try to add, say, more energy, electric vehicle charging stations or more solar, I'm going to have these complications. But the other aspect is around really becoming more dynamic with hosting capacity. So determine where improvements can be made. So that can be, can we optimize with the tools that we have now? Are there other controls that need to be put in place that can then more easily enable us to take on more hosting? Or does some true network reinforcement have to happen? So it's really about increasing the efficiency of processing this information, customer connections coming in. Can we validate those? And all this is a process, as you can imagine. And another example is connections assessment. So being able to do what if analysis around, if I have certain customers connecting at these locations, when will I potentially have an issue? I may not have one now, but I have certain neighborhoods or certain areas on my grid where I'm adding more load, or I'm having more development, or I have a large industrial commercial customer looking to connect a new facility. These kinds of things can be part of these intelligent forecasting tools and part of the network simulation. And overall, this enables lots of different planning scenarios. So you can have various scenarios to then determine if I need to reinforce the grid, this is when I need to do it. Or I don't need to do it today, but I need it in 5 years. Or if I implement these other processes or software solutions, I can defer that for a bit longer. All of this is really setting the stage for making really important decisions, because we really see a trend where planning and operations processes are really starting to converge and come together. So Sadi, maybe you can help us on the operating side of things.
Absolutely. So just building off of that point, with the planning and the operations converging, really there's a lot of ways in which these also influence each other, right? Because the more DERs can be deployed, if these DERs are being operated in a way that facilitates and enables active grid management. So in addition to monitoring and visibility into all the connected DERs, as Alexi talked about, but using this enhanced awareness and a more accurate view of the network state to then drive dispatch decisions for these DERs is what a comprehensive approach enables you to do. So especially when you're talking about behind the meter assets where visibility into these DERs is low for grid operators, how do you provide insight into the available flexibility that's coming from these assets, whether it's energy storage, electric vehicles, microgrids, load resources, and the flexibility associated with individual assets, but also grouped in a way that's network relevant and network aware. And then using the information that we know about the network state to then optimize and dispatch these assets also enables the utility and the operators to really involve and enable the end consumer, who's becoming more and more of a prosumer. We are also seeing this emerging concept around dynamic operating envelopes, which is essentially a way of saying that if we need to be able to support more DERs on the platform, then these need to be operated within certain limits so as to be safe and reliable for the grid. So just using this information and then optimizing these DERs in the context or within those constraints also becomes a technology solution. And then finally, with more utilities planning virtual power plants or VPPs as peaker plant replacements, and these are also becoming a very integral part of their integrated resource plans, they will need a technology solution or a platform that's capable of operationalizing this VPP, but also operating it in accordance with grid constraints. So having the ability to deploy multi-asset VPPs that will enable the widest range of DERs means that more customers are supported in their journey and desire to become prosumers. More assets are connected and visualized, and there's enhanced situational awareness coming from that. And these are being operated in a way that's safe, reliable, and contributes to the overall goals of the utility or the energy company.
Mm-hmm. Interesting. So, obviously your two companies have been extremely active in this space. So to pivot a bit, I'm curious if you could all just speak to some of the key differentiators that you see of Schneider Electric and AutoGrid in relation to some of your DER management platforms.
Yeah. So Schneider Electric's strategic investment in AutoGrid has been focused on bringing comprehensive solutions that bring the strength of the technology platforms that we have to bring a broad and comprehensive approach to DER management that's value, use case, and workflow driven. So this provides utility operators a full view from the grid to the prosumer. It enables them to aggregate, optimize, and connect and control all DERs, whether they're front of the meter or behind the meter, and just operate the grid and the existing electric infrastructure in the most efficient manner possible. The global presence and ADMS experience of Schneider Electric, coupled with the extensive DERMS and flexibility expertise of AutoGrid, is what this combined offering brings to the industry. So combining grid and economic constraint management, because grid constraints are, the main concern of a utility operator or a control room operator. Economic constraints, especially if you're connecting to, controlling, and optimizing end customer assets, you need to be able to ensure that they're getting value out of it, and the market and grid priorities being met met together is what we believe a comprehensive DERMS platform should be able to do. So bringing customer services, energy markets in alignment and in coordination with grid planning and operations will enable grid operators to accommodate the maximum number of DER deployment and penetration on the network. And more importantly, there's immediate value that we can deliver based on the functionality that's available today. And as the utility and energy company needs evolve, especially in the context of changing regulations such as FERC Order 2222, we can meet the evolving needs of utilities as well.
Yeah, I'm also thinking, Sadia, an idea that might help too is a bit around use cases, because we really work with our customers and we've walked through many different use cases about how they're going to have a stepwise approach on their journey for managing more DER and becoming more digital, and thinking about how they're going to offer a whole set of new types of services, their business model changing quite dramatically. And what's been really great about all the collaboration is, I'll start I'll give you a stepwise journey perspective. So when we start thinking about modeling DER, the types of them, the locations, are they dispatchable, what size, these kind of metrics, sharing across information that the customer service department has, for example, managing customer connection requests, facilitating and validating those. There's a lot of things that across customer service, asset management, planning, operations, they all have to have this latest view and have to share this type of information. And just think about things about adding and removing DER. What about if the availability status changes, or the program that a specific customer or resource is participating in changes, or there's a change in the state of the grid and how through the network topology where a specific resource is fed from. So all these things are important factors and are quite dynamic. So thinking about sharing these informations and how to do that is important. And really, this is all about situational awareness. So, we think about also adding on top of the modeling, but now what about current status of the event? So if there's information coming through maybe a third-party aggregator that has status information about a distributed resource that the utility doesn't have direct telemetry to, then that's really valuable information. So let's tie this to that model and share that data. And then, for example, so when there's a demand curtailment, an event is scheduled, what about that? So historically, operations of utility generally don't know about maybe what historically have been demand response events. And as demand response becomes a subset of overall DER management, again, that can be quite impactful. And if you're really thinking about having an awareness of how the grid is operating now and in the future, this kind of information is really important too. And then as I flow into real-time constraint management, the goals are to detect and mitigate constraints. And so now if we could detect in real time by using that available telemetry, but also the calculated network state, then we really can help specify what the constraint parameters would be. So if now from a grid constraint management, we need to dispatch resources, and we can do that through flexibility services that already have the architecture and the agreements in place for the resources that are participating, then all of that is connected. And now we have lots of different ways to optimize and look at resources as valuable assets. This also can be done for look ahead. We talked a bit about that, thinking about hour ahead, 4 hours ahead, day ahead. And that really starts requiring predictive analytics and scheduling. So that kind of information is shared. And I guess I would like to maybe finish just by a couple specific case study examples. So we see regulations and the priorities and challenges that vary quite a bit across geographies around the world. And so, for example, in the UK, active network management is a principle that's really been gaining ground. And a lot of this, I guess, imagine a constraint that's forecasted for the following day. And a grid operator needs support from DER to address it. The existing infrastructure can't quite accomplish it. So this enables, so if you have a flexibility market, which we have in the UK, so now you can create competitive bidding processes to get access to more and more flexibility. So it starts with things such as the concept of look ahead, identifying a constraint, knowing where customers are, which assets are in what location. Is that a large area? Is it a smaller area? And then making the request and creating what they call a merit order. So the merit order list that prioritizes things across pricing, about available resources, have they been dispatched recently, where is their precise location? And based on that, it may be a subset of the total number of resources in the area that are needed. And then that can be sent for a bid process. And based on the winning bids, that is then shared back to the real-time constraint engine. So when it's time to execute and dispatch, that order, that list is already defined and ready to go. So this kind of activity is really intriguing. And you can see how that's really advanced, and even more so than a lot of places we're seeing in the US. In Australia, Asada, you mentioned dynamic operating envelopes. Yeah. Really, you could take that whole example I just described and then start thinking about making it even more efficient. So now if you do provide these upper and lower limits on the import or the export of the power for individual resources or a group of DER, then with this dynamic approach, which requires more advanced analytics, now you can vary and adjust these limits on more shorter time intervals. So it's not just a 4-hour window request, but that can be more granular. And as you fine tune it more, then you're applying this dynamic dispatching that enables even more maximum value of these connected resources. So a lot of this comes full circle, and these examples are, well, they're really quite exciting.
Thanks a lot, Scott. I think to step back from these very exciting examples in Australia and the UK that we've been implementing together, I think to summarize, really Schneider's approach to DR management is really to deliver grid efficiency, reliability, and sustainability, and connecting DR owners and prosumers. So the deployment of this needs to be stepwise, as we discussed initially, simplified, and modular, so that we can fit with the desired use case, value streams, workflows, but also the existing state of the grids. There, as you said, their level of instrumentation, the availability of data, that is going to be the base for more accurate forecasting and running AI. So we're passionate about supporting and evolving DERMS management with our customers and drive together with them their journey along this new energy landscape. Whether their challenges require more basic or complex requirements, our recommendation is to deploy capabilities that meets the needs of today, and with a plan to address on how to address the challenges of tomorrow. And we believe that together with Autogrid, Schneider Electric and Autogrid, we have the set of solutions that allow these stepwise, modular, and adaptable ways of addressing these short and long-term challenges of DERMS. We're going to be present at Distributech from 23rd to 25th of May in Dallas. We'll have really some exciting announcement related to DR management, and we'll have our DERMS team and our specialists ready to discuss and demo our capabilities with with the Autogrid team. Sadia, I think you'll be there. It's going to be exciting. Scott as well. We really look forward to the future ahead and continuing this discussion with you to bring how to bring value through DERMS, and would really be excited to see you in Dallas or to connect otherwise. I think I hand over to Mike at this stage.
Perfect. Thanks, everyone. Much appreciated. Very valuable insights. So I'd like to open it up to one or a few audience questions here. One that just came in is it expensive and or complex to implement one more comprehensive implementation of DERMS?
So I can start that off. The simple answer is no, right? Because both Autogrid and Schneider have independently deployed their solutions with various utility customers. And Autogrid has taken this journey with several of our customers where we start with something very specific that addresses their needs and requirements today. So it may be a simple demand response program that's focused on thermostats, and then they're expanding that to EV, VSE management, and then now more recently to storage and microgrids and utility scale storage solutions as well. So we've taken that journey with our customers where we start with something simple and either continue to add more complex use cases depending on the evolving needs of the utility, or add more assets on the platform. And all of this is done in a way that delivers high levels of business value to our customers. So the comprehensive solution really is to do exactly that, but by bringing the technology solutions across both Schneider and Autogrid to do more more complex things as the needs of the grid and the utility and various teams evolve over time. Scott, would you like to add anything to that?
Yeah, I think what's interesting about this is there's such different ways to deploy and get access to these kind of capabilities, because the idea is not to overprescribe or to necessarily get ahead of what you need. And I think there's a lot of flexibility here to start with simple deployments that address this very specific locations on the grid. You're not solving your entire service territory. You can get the specific requirements addressed case by case. But I think most importantly is to map how that journey might look at over time. And whatever decisions are made, those can be adjusted as you go. So you might determine that you're getting more business value out of this specific operation than you intended, or less. So part of it is understanding the value you can get. That might then affect different programs that are created and rate structures. So we see customers that have maybe longer term, bigger plans around this. But the idea is, what can they be doing today? So I think flexible deployment models, lots more cloud technology. You can get things set up faster and implemented easier. There's a lot of dynamic nature about capabilities over time. So with that kind of deployment, you get benefits of new things being developed and can more easily update systems. So I think really it's a matter of what is needed to solve, aligning on what that is, and implementing the capabilities to meet that need over time.
And maybe I'll just emphasize on one word that you said, Scott, because you talked about flexibility and modularity, but you also talked about cloud.
Yeah.
And I think that just as a teaser, I think more and more you'll hear us communicate on how cloud can be really an enabler and an accelerator to deploy DERMS solutions. So we're really fully leveraging this technology to facilitate the penetration and implementation of DERMS.
Yeah.
So here's another question from an audience member. What is the best way to manage voltage levels, and how can we reduce electricity consumption and increase efficiency?
Yeah, there's various ways to do that. We see examples. I'll give you another interesting example that's happening also in Australia, where you have such a high deployment of solar PV, say rooftop and other, could be community solar, and especially where there's low load. So if it's on locations of the grid that during the day there's not a load, especially when you get to weekends and holidays, so there's a lot of overproduction, that can create overvoltage issues. And I think what you end up being able to do is you could deploy and dispatch solar in a way to curtail that capability at certain times. And really, if that allows the utility to take on and connect more and more solar, it's better overall. But now it requires a little bit of flexibility to do that. There's also interesting cases of almost like a reverse demand response capability where you're increasing load to supplement it. So I think, but also, how does this fall into the context of maybe other voltage management processes utilities are using? So now these new grid-connected assets that are third-party or customer-owned can participate in voltage schemes that are leveraging voltage regulation, capacitor banks, and other more traditional devices on a grid. And by working holistically, you really enable more and more connection to these resources. So voltage management is a really key use case and one that we're supporting quite well today.
Yeah, and sorry, go ahead, Mike. So just to talk about the other part of the question around how can we reduce electricity consumption, I think we need to move away from the regime of thinking about flexibility as primarily load curtailment. So it's flexibility goes both ways, as Scott alluded to, right? So it's not just about reducing load and reducing load, whether it's system-wide or in specific parts of the network, but in certain cases, it could be increasing load. When you look at utilities in the US, a lot of them are trying to influence behavior in terms of EV charging through tariff structures, where they're saying if you charge at night where renewable production can be really high, then it would be half the rate that you would normally pay, or in certain cases it would be free of cost. So it's really flexibility that we're trying to deliver as as a value to utilities, because it's not you may require to increase the load under certain circumstances depending on what the conditions of the grid are. And traditionally, we're also used to thinking about these kinds of flexibility strategies in the context of events or seasons rather. So, the summer season, we want to do load curtailment, and now we're starting to see that happen in both summer and winter. But you're going to start to see the need for flexibility really pretty much all year round as more DERs get deployed, as consumption patterns change over time, as there's more electrification on the grid. And this is going to be something that you'll require 24/7 and not just during very predictable times of the year.
Great. So another question that we have coming in. So you mentioned a couple of implementation examples. Could you briefly describe some additional examples that cover various use cases and requirements?
Yeah, I mean, I guess I could give a couple examples. The idea is we've seen a lot of different projects that are doing just kind of what I said, where they're focused maybe on a specific need. So we have all the way from examples from deploying smaller scale distributed energy storage in distribution grids to see how they also can be aligned with where there's a lot of solar penetration, for example, or maybe electric vehicle charging, and how that can help offset and be optimized. And questions come up about, well, who would own those resources? Can the utility also be a participant in owning those resources? And I think by us proving out the value, that helps the entire regulatory environment understand better about, oh, this is actually proving it out well. It makes a lot of sense. There's got to be new ways we can think about doing that. And that's an example here in the US. And in Germany, we have more and more EV charging. So when you're thinking of more large charging stations, rapid charging, fast charging, and the idea that's a significant amount of load. In a lot of cases, utilities might have a location where that connection is requested, and they have to derate the overall capacity because they just can't quite support it. So the way to optimize other resources around that can then allow you to maximize that capacity. And that really differs. Maybe in some cases, at some point, more infrastructure, higher capacity transformers and lines need to be built, but that's usually a longer term play. What can we do in the meantime? Dispatching microgrids is another really good one. Seeing the capabilities and the value they bring in a coordinated way, we really think that's quite intriguing. I think the outside of that, it's really about types of resources, where there's a constraint. Non-wire alternatives is another. So you can solve one specific example only, but have started a framework that lets you do more. And we have some examples of that in North America too.
Mm-hmm. And especially with the use of behind the meter resources and DERs that are deployed on end customer sites, customers of ours and AutoGrids, they've used and dispatched, just an example from last summer, our platform was dispatched over 1,800 times, 37 gigawatt hours of flexible energy was delivered at a time when the grid was most stressed. This spanned events, in the summer season, in the winter season. So we're starting to see a lot of real world examples and use cases where this type of active management involving DERs and delivering flexibility for better grid management, and it's all happening now at significant scale. So we're only going to see more and more of the need for this type of coordinated approach, because when you're talking about deploying assets that collectively have the flexible capacity associated with a peaker plant, that's a significant impact on the grid, right? So that's going to, knowing that and having visibility into it, even if it's just demand side resources, and then having that coordination across teams will become more important over time.
Great. So I think we're just about at time here. So again, I'd like to thank each of the speakers for your valuable insights today, to all the audience members alike. Now, if you'd like some more information on some of the concepts discussed today, as well as a deeper look at the Schneider and AutoGrid platforms, I'd point you to check out the Guidehouse Insights recent DERMS leaderboard. The link to the report should be able to be found in the webinar description. So again, thanks to all involved, and I hope everyone has a great rest of their day.
Yeah, thank you. Thanks, Mike.
Thank you.
Thank you.
Thanks, everyone.
Bye-bye.